Hello everyone. In this video, we will be writing our first code of deep learning using TensorFlow. This tutorial will serve as a hello world of deep learning. Here we will try to implement this function using deep learning. Or I can say that we will create a simple neural network that will try to mimic this function. Throughout the tutorial, we will see that how does the simple human brain try to solve this problem, and then we will see that how does deep learning relates to that, and then we will try to create a simple neural network, or I can say simple model. And during the process we will see that which libraries do we have to import, and what our input is going to be, and then we will see how to create or instantiate our model, and then we will learn how to train this model, and then we will see our predictions. So without wasting any time, let's get started. So first of all, we are trying to create this function using our neural network. Let us see that how does our human brain, how does human logic try to solve this. Let us suppose that this represents my x. All of these values are my x values. This is my x1, this is my x2, and so on. And these represents my y values. This is going to be my y1, this is my y2, and so on. For a particular value of x, I get a particular value of y. Here, whenever x is -1, my y is -3. Whenever x is 0, my y is -1. And whenever my x is 1, my y is 1. So basically, these are my x values and these represent their respective output values. So we have to create a function that will try to solve this problem in such a way that whenever I feed this value of these values of x, I will get these values of y. So let us try to solve this problem on our own first. So the method that we are going to implement is going to be basic hit and trial. So let us first try to square these x values. So the square of -1 is going to be 1, and this does not match my y value. So this approach is going to be wrong. Let us cube my values. So if I cube the x1 value, that is cube of -1, the output is going to be -1, which does not match my y. So again, this approach is wrong. Now let us try to multiply my x with 3. So if I multiply my x1 with 3, which is basically -1 multiplied by 3, I will get output as -3, which matches my y1. So this condition satisfies for my x1, that is y is equal to 3 times of x. Now for the second case, for x2, my x2 is going to be 0. So 0 multiplied by 3 is going to give me 0, which is not equal to my y2, which is not equal to this value. So this approach is wrong. So after furthermore hit and trial, I can say that if I multiply my x by 2 and subtract 1 from it, I will get y. So when my x is -1, I multiply it by 2 and then subtract 1 from it, I will get -3, which is equal to y1. If my x is 0, so 2 multiplied by 0 minus 1 is equal to -1, which is equal to y2. And when I'm going to take x3, so 2 multiplied by x3, which is 1, minus 1 is going to give me 1, which is equal to y3, and so on. So I can say that this function, that is y is equal to 2x minus 1, satisfies my this condition. So now I'm going to implement this function, or I can say I'm going to create a neural network. I'm going to create a neural network that will try to mimic this function. So let us start by importing our necessary libraries. So I'm going to first import my TensorFlow. So I'm going to write here import TensorFlow, and then I'm going to import my NumPy library. I'm going to write here import NumPy. Now it will be a very tedious task to always write the whole word TensorFlow. So whenever we have to use TensorFlow, we will have to write the whole word. So in order to avoid that, I'm going to be using TF as an abbreviation for TensorFlow. So whenever I am going to write TF, it will mean I'm going to be using TensorFlow. And for NumPy also, I'm going to write here as NP. Always whenever you will be using a TensorFlow, or whenever you have to use functionality of NumPy, you have to write TF or NP. So now I'm going to run my code by pressing Shift and Enter together. After that, I have created my sample input. Here, X represents my X values. So my X starts from -1 up to 5, and Y starts from -3 up to 9. So for value of X, so whenever X is -1, my Y is going to be -3. Whenever X is 0, my Y is going to be -1. And whenever my X is going to be 5, my Y is going to be 9. It is the same example that we saw earlier, right here. Now I'm going to instantiate my model. That is, I'm going to create my model. In order to create my model, I have to define two steps. The first one is going to be sequential, and second one is going to be dense. And dense is going to be inside sequential. So basically, I have to write here. First, I'm going to make my model. I'm going to define a variable that is going to contain my model. So I'm going to write here model. Now, I'm going to first use a model that is sequential. That is, my model is going to be sequential. In deep learning, by default, whenever you are creating a neural network, whenever you are going to create a neural network, it will be sequential. That is, each layer is going to be connected sequentially, where I will give input to one layer, and that input will go as that layer will give that input as output, and that output is going to be fed into another layer as input, and so on. So I will pass my input from here and I will get output from here, and there will be several layers stacked in front of each other sequentially. So that's why by default neural networks are sequential in structure. So a neural network model is going to be sequential, and since each neural network is going to be densely connected to each other, each neural network is fully connected to each other, hence our model is dense. That is, my neurons are fully connected. So whenever you will be writing your dense step, it simply means that first of all, my neuron will receive my input. So my input will get multiplied to the respective weights, and a bias will be added. And after that, this whole thing will be passed inside an activation function. So this whole step, that is multiplication of the weights and the inputs and addition of bias, and then the whole stuff passes inside an activation function, and then you will be getting an output. So this whole step is implemented by my dense layer. So I'm going to be writing here tf dot keras dot sequential. That is, my model is sequential in nature, and then I'm going to write my dense, since my neural network layers are fully connected to each other. So I'm going to write a tf dot keras dot layers dot dense, and then since I'm going to be creating a very simple neural network, which means that I'm going to make sure that my number of neurons inside my layer is going to be 1. And whenever you are going to create a neural network, whenever you are going to create a sequential neural network, so in the first layer, you have to pass your input shape. Since this is a simple neural network containing only one neuron, therefore, I'm going to pass here my input shape, and my input shape is going to be 1, because here my input has dimensionality 1 only. So I'm going to write here input shape is equal to 1. Now I'm going to run this. So in this way, I have instantiated my model, or I can say that I have defined or created my model. Now I'm going to train my model. So in order to train that, I'm going to write here model dot compile, and then I'm going to first pass my optimizer. I'm going to be using my stochastic gradient optimizer, so therefore I'm going to write here SGD, and then I'm going to be using mean squared error as my loss. So I'm going to be writing here loss is equal to mean square error, mean underscore squared underscore error. So this is going to be my mean square error. So what this step is going to do is that my model, whenever I'm going to pass input to my model, it is going to give an output. So what is going to happen is that my loss function is going to calculate the difference between the actual output, that is the actual that should actually come, and this predicted output. And depending upon my different loss functions, different values are calculated. Since here I'm going to be using mean squared error, therefore I'm going to calculating the summation of squares of difference between the actual and predicted outputs, and then I'm going to take the mean. So this is my mean square error, and my main function is going to minimize this error. Now since when we were trying to calculate, what we were guessing what our function should look like, and depending upon my value, depending upon my earlier guess, I was trying to improve my guess in order to form the correct function. Similarly, my model will try to minimize this loss so that my predicted output tries to approach my actual output. And in order to do that, in order to perform the guesswork, optimizers are used. So it is the purpose of my optimizers to do the guesswork. So if I'm suppose getting some large error for particular value of weights and for particular value of weights and bias, I am suppose getting a very large error. Now my optimizers will guess a new value of weights and bias, and depending upon that, my if my loss decreases, then my optimizer will continue to move in that direction, and if my loss somehow increases, my optimizer will try to change my weights depending upon that. So this is how my optimizers work. After this step, after I've run this, now I'm going to fit my model. So in order to fit it, I'm going to write here model.fit, and inside the brackets, I'm going to first pass my input, that is x, and then I'm going to pass here y, and then I'm going to be writing here the number of epochs. So model.fit is a process of training a neural network where my neural network will learn the relationship between my inputs and the outputs. Now I'm going to run this, and x is not defined. Okay. Once this is done, I will be making my predictions. So once this is done, I will start by making my predictions. So I'm going to first predict what my output is going to come if I send my input as 10. So what we have done is that we define the function to be 2x minus 1 is equal to y. So if I pass my input as 10, my output is going to be 2 multiplied by 10 minus 1, which is going to be equal to 19. So my output should come to 19 or close to 19. So if I run this model.predict, my output is coming to be 18.83. Okay, not bad. So if I try to increase my number of epochs, so if I write here number of epochs as instead of 300 to, if I do it 500, and now if I again train my model for 500 times and then do my prediction. Earlier my prediction value was 18.83. Now if I do that, my accuracy has increased. Now my prediction is coming to be 18.98. That is pretty much close to 19. But why I'm not getting 19? The answer is simple. It is because we are dealing with probabilities and not certainties. So neural network tries to calculate the highest probability. So my neural network tries to calculate the highest probability that my answer comes. So my neural network tries to calculate the highest probability. But since I have given only 6 inputs here, you can see that I have given only a few number of inputs, my 6 data points. My model cannot perfectly answer my query. Therefore, my result is very close to 19 and not exactly 19. Later on, we will try to see how can we deal with this. But that was all for today, guys. In this video, we tried to implement a simple neural network in order to mimic this function. We learned that what necessary libraries we have to import, what is sequential, what is dense, and then we learned how to compile our model, and then we learned how to fit our model and make the predictions. So this was a very basic introductory lesson. In the next video, we will try to get more intuition from this network only, and we will meet in the next video. Until then, bye bye.